So cosine 2x is the same thing as cosine squared x minus sine squared x. So I substitute that in for that. And then minus, x, minus cosine x is equal to 0. Now there's three things on the chart if you can look back in your notes. But I just remember this one thing so that I don't have to remember the other two. And then if I need to adjust something, I can remember the Pythagorean theorem, the main one that I remember. And if I need to adjust, I can. So I can say cosine, and I do need to here. I'm going to say minus. This is the same thing. If you solve it for cosine, if you solve it for sine, you're going to get 1 minus cosine squared x. That'll be the same thing as sine squared x. Minus cosine x equals 0. So I just replace that because I want cosine, not sine. And now I'm going to have 2 cosine squared x, because negative makes a positive. I'm going to have a negative cosine x, and I'm going to have a negative 1. And then, just to help myself think about it, I'm going to replace the cosine with just x, and I'm going to say 2x squared minus x minus 1 equals 0. And I'm going to say, can I factor this? Can I factor this like this? And I say to myself, well, let's see, the middle term is supposed to be negative, so there we go. And here we get 1x, and there I get negative 2x. I think that works. I believe that's true. So let me substitute back in cosine. I'm going to have 2 cosine x plus 1, okay, times cosine x minus 1 equals 0. Okay? And hopefully you can see that if you FOIL that out, or whatever, however you do multiplying binomials together, that you get back to the same thing. Hopefully you can see that. They are the same. And so now let's go ahead and use that. We want to know, when is this first one equal to 0? Well, when cosine, we can solve it for 0. We can set it equal to 0, but if we do, we're going to find that cosine x is supposed to equal negative 1/2. If I put this in for negative 1/2 in there, 2 times negative 1/2, negative 1 plus 1 is 0. Okay, so that's the first one. And for the second one, cosine x would have to equal 1. If that was a 1, 1 minus 1 is 0. Okay, so those are my two situations. Now let's see, I'm going to run with those. When is cosine x equal to negative 1/2? Well, I guess I'll draw coordinate axes here, and I'll put it in the second quadrant because I know it's at least negative there. And I'll say this, I'll say 1 is the adjacent and 2 is over here, so I'm pretty sure that the square root of 3 is over here. From my reference triangle, I remember that. And I say, well, let's see, what's the one that opens up? Oh, that's 60, right? So I would call this, since I'm in I'll say pi over 3 for 60, but I really know that x is equal to 2 pi over 3 because I'm in quadrant 2. And also, same thing happens down here in quadrant 3. X is negative. It will give me a negative value. So I'll say 4 pi over 3. Those two values. And then the question is, where is the cosine of x1? And the answer is at 0, right there. If I don't even swing anywhere, that way or this way, if I stay right there, the cosine of x is 0. So the cosine of 0 is 1. So x is equal to 0. So these are my three values, and I should be able to confirm that. Let me box these so I can show. These first two come from there, and the second one, the third one comes from the second part. And I kind of look over my equation just to make sure that I'm okay. It seems legit. And okay, so now I go to my graphing utility. They told me in the problem to graph, and so I'm going to. And they limit me to 0 to 2 pi. So let me go over there and check my answers. I've put it in, of course. And let's see here. there's one answer, 2 pi over 3, and 4 pi over 3, and oh yeah, 0. Those are the 3 places where it hits the x-axis before it gets to 2 pi. I'd include 2 pi, but they won't let me. So there we go.